Hello and welcome back to another problem. We have lead code hard here for Lincoln today.
hmm
so yeah, let's get started. Yeah, so basically the problem statement's over here. Um, Given an array of integers nums, there's a sliding window of size k, which is moving from the left to the right, and you only let us see k numbers in the window. We want to return what the maximum value is for each sliding window in the form of an array. So yeah.
Right. Okay. Um, are there any are there any limits on K?
So the limits for
Or I guess what are the problem restrictions?
so the problem restrictions, let me quickly. Okay, so yeah, so basically problem restrictions is k has to be less than or equal to the length of the nums array. And
hmm
then yeah, and then basically just like assume what is it? Yeah, like no, like the value can be like basically negative and positive, but it has to be an integer. Yeah.
Right. Okay.
So
Um,
yeah, to like kind of like quantify it. Here it
right.
is. There we go.
Okay. So I think maybe it would be a good idea for me to kind of walk through an example.
Mm-hmm.
Um, so let me go ahead and just make one on my own. I know you give me one here, but I'll just use the one that you give me.
Mm-hmm.
So um, So the sliding window starts by occupying the first three elements. And then as -3 comes in, the max remains unchanged.
Mm-hmm.
Um, and then only once 3 goes out of the window does the new max update. Um, so some things I'm noticing here from this example
Mm-hmm.
is the chance to identify a new maximum happens as one of two causes. A new number enters the array, or the old king leaves the array. Um,
Mm-hmm.
okay, so I think so. Generally, with a sliding window problem, the very broad, high level description that I find works is that the sliding window incrementally. So the sliding window, a sliding window solution will have some sort of data structure or a couple of data structures that store information. And as the window end increments down the array, that data structure updates.
Mm-hmm.
Um, Now, in previous sliding window questions, it's been so that that data structure updates and then the window at the back contracts until a certain condition is met.
Mm-hmm.
But because the sliding window is fixed, um, my guess is that we have a for loop that loops through the numbers and that represents the window end. The
Mm-hmm.
window start is fixed as 3 items below that one, or to the left of that one. And as numbers come in, we increment that data structure. Um, so I will be honest. I've heard of this question before.
Mm-hmm.
I definitely don't know the solution, but I know that it's a stacks question.
Mm-hmm.
um,
So you wait. Sorry. You know it's a stack question.
yeah, like I'm pretty sure it's a stack question, isn't it?
Um. Well, I'm sure there's like ways to implement it with a stack, but to my understanding, you can use like a DQ for it, or like a deck way.
Do you mean like a queue?
Oh yeah, like a queue. Yeah.
Right. Oh, okay. I
Or
might have just remembered
I
wrong.
think you might need it to be doubly ended, but
Okay. Um, okay, so I'll go ahead and mention the brute force solution. So the brute force solution is that I increment down the array and I group three at a time and I just find the max. Now,
mhm,
the problem with that is that the time complexity is going to be O of kn, because you're going to be doing k operations to find out the maximum in a window size k, and you're
mhm,
going to have to do that n times for each element in the array. So I know that time complexity is not good enough for you,
yeah.
and also because it can scale up to O of n squared if k approaches n.
Mhm.
Um,
Oh, also, one small thing.
mhm.
It's it can be also considered as O of like O of k times n minus k, because like you don't actually have to like traverse through every single element.
Right.
It's just
Yeah.
up until there. Yeah, yeah. Just small thing.
Mhm.
Yeah.
Yeah. Um, for sure. Uh, hmm.
And your approach with the brute force is correct. Yeah.
Mhm. But I think I don't think it's too much. There's too much value in coding it up,
Hmm.
um, because it's a very simple solution. Hmm. So elements in a queue come out when they're old. So if I were to incrementally add numbers to the queue, then they would just come out in the order that the array is in. Um,
Hmm. Would you like me to kind of like give you a small hint?
yeah, sure.
Okay, so for if you take a look, I guess like at like the first row over here, and
Hmm.
like you know that the maximum of this one is three, right? And
Yeah,
then
that's right.
for the second one, you also notice the maximum is three as well, right?
Hmm.
Do you need to check like all of these values in order to like, oh sorry, yeah, do you need to check all of these values in order to figure out what the like what the maximum is? Like if you move it forward one, do you have to like recheck it again for everything?
No, I don't. And the reason why is because, like I said before, the update can happen in only one of two scenarios. Either a new king enters or the previous king leaves. In
Mm-hmm.
this case, a new king hasn't entered. Negative three can't win three, and the previous king hasn't left the window.
Mm-hmm. Is there can you think of any way to utilize the queue in order to, you know, like take advantage of that?
Mm,
Hmm.
do I? Maybe I have a queue where numbers are added
Mm-hmm.
only if so as I go through and discover new numbers, as the end of the window goes through and discovers new numbers,
Mm-hmm.
it gets added to the queue only if the number is greater than the current maximum. And the number doesn't get added by itself. It gets added alongside the index at which it was positioned. So every time I go through and the window moves, I expire. Like I take a peek at the queue and
Mm-hmm.
I expire numbers that have made it out of the window position.
Right.
Whereas I only keep in track the numbers that, so I only keep in track in the queue the numbers that are worth being there, um, which would be numbers that are bigger than the current maximum.
Right, right. Yeah, that's you're on the right track here. And to sort of expire this from like the DQ, um like what would you have to do in order like, I guess you've already mentioned it, right? So you have to like only like
Mhm.
keep like one value and expire the other values, right? Can you like elaborate a little bit
Right.
more on that?
Yeah, so the number gets stored not only by itself, but also with its index, right? So on every iteration when the window moves, I check to see at the end of the window, the index of the end of the window is greater than the index of whatever is peaked from the queue. So I peak the queue, and let's say in the example of line 19, um, where the max is just updated 5, and the window is exactly in the middle of the array. Um, so in that example, 3, the old king, has moved out.
Mm-hmm.
So the queues, kind of the back end of the queue, um, or the end that's about to leave, would have stored the tuple saying 3 comma 1. So I peek that. I see that 1 is less than the current window position end, which is 2.
Mm-hmm.
So I pop it out of the queue and, in a sense, expire it because it's no longer being kept track of.
Mm-hmm. Hmm. Okay, so I see like your current process right now like utilizes like a tuple in order to like keep track of it, right?
Mhm.
So, hmm. Okay, okay, let's say like there is a way to do it like just like listening to what you're saying right now. I think you can use a
Mhm.
tuple. However, there's also a way you can do it without. And to kind of like explain a little bit
Right. So
further.
just the number by itself.
Yeah, just a number by itself. And like
Mhm.
what do you like what is it that you like really need? Um like what do you need for like to stay in the queue as you like slide the window forward? Like think about it, like let's say like you move like this to this. Like what's like the
Mhm.
value you need in the queue?
Well, 3 is the most important one because it's the maximum.
Hmm.
Um,
So you since three is like the most important one, like you don't really like need the other ones at all, right?
uh, well, I wouldn't unless 3 leaves, and let's say it wasn't -1, -3, 5. It was if it was -1, -3, -5, then whatever data structure that I'm using would also need to store -1 in case that 5 doesn't take over. -1 would have to.
Hmm. So so basically like you're saying like if three leaves, then you'd have to also keep track of the negative one as you move it forward.
Yeah, in the case that the 5 is a -5 instead.
Uh-huh. Um, Circling back to the question you had earlier about keeping track,
Hmm.
what if instead of deleting everything, like besides the maximum, you were to store it somehow? So like let's say like imagine you had some sort of like a stack or a queue or something like this, right? So you have
Hmm.
like like 8, 7, 6, and then 9, and then eventually you want it to slide, so it becomes like this, right?
Uh-huh.
So like the issue with before is that if like we have like the stack of the queue or something, like if you were to move on to this one, then since like we move everything except like 8, once eight's
Hmm.
removed, then it'll be gone, right?
Right.
So what if we um add, okay, so we have like a DQ here, right? What if
Hmm.
we add like so the first thing obviously is to add 8 to the queue, right? Um
Hmm.
and then like we check to see like what the next value is. It's 7, right?
Hmm.
And 7 is like less than 8, right? So it could be a potential successor, right?
Yeah, that's right.
uh you could then like store that, right?
Hmm.
And like you could store it like let's say like you could store it in the DQ, for example, and
Hmm.
so on and so forth. When when it does move on the sliding window and the 8 is out of bounds, what would you what would you want to do like to the DQ?
Well, I'd want to pop out seven. Sorry, I'd want to pop out eight.
Right, right. And then like like for their final result array, since we're trying to like get the maximum, what would the maximum value be in this case? Like for like let's say like it's a really big really big like array, right?
Hmm.
Um like six, like et cetera, right? Um
Or do you mean nine, seven, nine, or
okay,
no, eight, nine? Would it be?
okay, um so for
Oh no, no, I see what you mean.
yeah.
You had eight, seven, and then you popped out eight,
Hmm.
so now you have seven, six. I
Hmm.
see what you mean.
Yeah. And like so like out of like this value like out of this one, what part of like the DQ would you want to what part of the queue would you want to pop out in order to like get like the maximum value?
I would, well, as it is right now, I would just pop normally to get the max value.
Right, right, yeah. So you would like get seven, right?
Yeah, that's right.
Could you like utilize this with like within like the larger problem in order to kind of like obtain like the maximums?
I'm a little bit confused on like how this is special. Because this to me just looks like a queue that's keeping track of the numbers that are inside of the window.
Uh-huh.
So, like as new numbers come in, it goes into the queue, and then as they leave, they exit the queue, right?
Hmm.
Um,
But
but
then
right.
would there be any use in like for example you only want to store the maximum, right?
That's right.
And then like for numbers which are like larger than the maximum, you you would want to like okay like let me just yeah like for like, numbers larger than the maximum, you probably wouldn't want to like add it like append it onto here, right? Like or like oh, hmm.
I mean, I could if if it's a potential successor.
But hmm. Okay, so let's say like you add nine, right?
Hmm.
Um, like what would happen to these values?
Which values?
Like the seven and six.
As of right now, it'd stay because the window's three large.
Oh,
Like
sorry.
none of them.
Like this is the Q, like DQ, for example. Like oh, sorry. Actually, yeah. Like okay, let me go through it again. So like
Mhm.
you're at a eight, seven, six, and nine,
Mhm.
and you want to move the sliding window up forward, right? So
Yeah.
what you could do right now in order to have like a list of like the maximum values, you can append like eight, and then like subsequently you can like append like seven, and then like six, right?
Uh-huh.
When you move it forward to the very next like sliding window, like the eight is no longer valid, right? And
Yeah, that's right.
like we said before, we'd want to remove that, and then we want to
Hmm.
like check what the next value is, right? And
Yeah.
then like we add that, right? Like
Uh-huh.
um well, like in this case like seven and six would be like redundant, right?
Yes, that's right. Yeah.
Because nine is. So then you probably want to pop those values out as well in order to like get the maximum value, right?
But how would I know how would I know to pop them out if nine, like let's say the nine was a negative three instead.
Hmm.
So if it was eight, seven, six, I can't pop seven and six just because they're redundant. Because seven and six now become the successors, no?
So in that point, would you need to pop them out?
I wouldn't, no.
Right, because like that like then like you said like they would be the successors, and in that case like what's the value you want to grab? Um,
It would be seven.
yeah. Wait, hold up. To refresh the session. Okay. Oh yeah, I think you might need to refresh it too. Okay.
Oh, okay, okay.
Okay, okay, okay. Never mind. Okay. Anyways, um, so it would be seven, right? And uh, like do you notice like the position is always at the very beginning of the DQ?
You mean like the maximum?
Like yeah, like the maximum.
Uh, what if it was what if it was 8, -10? No, what if it was 8, -1, 6, -3?
Okay, so uh eight. You can keep me typing, right? -1.
Yeah.
Okay. So okay, let's do with that example. So we'll just put that down over here. Um, so in this case, what you would probably want to keep track of, like you were saying earlier, you want to keep track of let's say like wait, sorry, maybe make this into a sliding one. Uh,
So,
and k equals three, right?
um,
Yeah.
yeah. So the point that I was going to ask about was, um, say it was 8, -6. Sorry, 8, -1, 6, and -3.
hmm
My DQ would start as 8, -1, and 6, right?
Well, okay. So another thing you want to like think about is like whether or not like like what values would be useful like in like this iteration of like the sliding window, right? Um, like you said, like you'd want it to start off originally with 8, -1, and 6. Do you really need 8 and -1 for the start of the DQ?
Um, uh, I guess, I
Wait,
guess I,
wait, sorry,
uh,
sorry. Maybe that's worded badly. Like what? Wait, no, sorry, ignore that. What values would you not need?
I'm not super clear on the purpose of DQ, so I can't give a great answer. But I can say that 8 is the most important number in that window right now.
hmm Okay, so like if 8 were to disappear, then the next like what would the next best one be?
If 8 were to disappear,
hmm
then it would be 6.
Right. Um. Okay. So okay. Like let's say for now, like you have like eights and then like negative one and six, right?
Mhm.
Since we know that six is ahead of -1, doesn't that make -1 like unnecessary anymore?
I don't know if it's unnecessary because if the array we say was like 6, 8, -1, 6, -3, -3, -3, -3,
hmm
then um
So like this, right?
or uh I guess if if there is a in this specific scenario it isn't because -1 is wrapped by two greater numbers that are within k distance from each other. So right now, when -1 isn't necessary.
Okay, okay. Let's say how would you be able to modify this so it would be necessary? Like at what point would it?
Um, oh, I guess it wouldn't be.
Yeah.
Yeah, because there would never be a point where -1 is in the window, but 6 wouldn't be.
Mm-hmm. And the reason for that is because six is ahead, right?
Right, that's right.
So for the DQ, or like I guess like for whatever you want to call like that data structure over here,
Hmm.
wh- like all the values you would really need to store would be like 8 and 6, right?
Yeah, that's right.
And then for like let's say like going back to this example, you see like 7, 6, and -3, right? Do you notice
Hmm.
any kind of pattern like between like the two things like because these are like just like we kind of established that these are the values that we need, right?
Um, why's the -3 in the first DQ, by the way?
Oh, sorry. This is like the modified one. Like wait. Um. Okay, you know what? Never mind. I'll just get rid of that. Anyways, um, but okay, okay. I can just like I can just say it like basically this is a monotonically decreasing queue.
Hmm.
So every like the queue only adds it if the value is less than like the current like than like the last element, right? And the reason for that being is if a number is greater than like than like the values before it, then like it supersedes it, right? Like 6 for example, it'll always be used in place of like -1, right?
Uh-huh.
The only value you'd really need to store would be 8 because like like that's a larger number than 6 and that could potentially be used instead of it, right? The only issue is that
Right.
like if you move forward in the sliding window, it could be made redundant because it's no longer part of it, and at that point you'd have to pop it, right?
Right.
So like an idea would be to have like well the reason why this like a DQ would be needed in the first place is because you need to have some like an O of one way of popping the value 8 from the beginning because like let's say like oh it's out of the sliding window, you'd probably want to remove that, right? And for like the beginning you also might want to like add or remove that depending on like what the values ahead of it
Wait,
are.
hold on. You said the monotonically decreasing queue adds elements to it only if the new candidate element is smaller than the last element that was added, right?
So wait, I was saying like the value 8 will be popped if it's out of the window, pretty much, right?
Right. But so it pops if when numbers go out of the window.
Yeah.
And in terms of adding, then a candidate number gets added only if the previous number that was added is bigger.
Well, yes, well, it doesn't have to be just a well, it's like, yeah, like the previous number, yeah.
Okay. Uh, so let's say I start with this one. So I add 8 because it's empty.
Mm-hmm.
And then I add -1 because it's smaller than the previously added number.
Mm-hmm.
And then 6 doesn't get added anymore because 6 is bigger than the previous number.
Mm-hmm.
Isn't that right?
Yeah.
Then the problem is once the window moves forward, 8 expires, and the program thinks that the maximum is -1. Doesn't it?
Mm, hmm. Well, the thing is, like, you'd wanna like when you add 6, that kind of
Mhm.
like supersedes everything else, right? So you just when you add 6, then you want to remove like the negative. You just want to remove everything less than like 6. So like you remove like -1 and then you have 8 and 6 as your DQ instead. So like this kind of like it's like
Oh,
yeah.
so the DQ doesn't prevent candidates from being added. It kind of like digs out numbers until the condition is satisfied,
Hmm.
where the number finds a bigger number.
Yeah. And like this would be useful because you would pop it out if it's out of it out of like the like sliding window, and then otherwise it has like a next successor, right?
Right. Okay. So I'm imagining like 8, and then like a bunch of -1s, and then 6, and then a bunch of -3s, right?
Okay, 8. Yeah. -1 and then a whole bunch of oh yeah, 6 and yeah.
I can try typing it out real quick. So, oh, where's my cursor? Hello?
Oh,
Oh, my cursor is invisible.
oh,
That's crazy. Anyways, no, it's okay. I know where it is. So I have 8, and then I have -1, -1, -1. Yeah, let's say I just have a bunch of -1s. and then 6, and then -3, -3, -3, like this, right?
Mm-hmm.
So, uh, so when the window is at, let's say, let's say the window size is still 3, and it goes from 8 to the first two negative ones. So 8, -1, -1.
Yeah.
In that case, the DQ would contain 8 and -1. Um, so it would correctly read that the maximum is 8, and
Mm-hmm.
then when it goes through, it pops out DQ, and it correctly reads that the max of -1, -1, -1 is -1.
Right.
Um, and it keeps doing that until 6 comes in, at which point it takes over.
Mm-hmm.
So um, um, so the reason why the DQ works is because one, no number that is outside of the window will ever remain.
Mm-hmm.
Two, numbers don't um, numbers don't make it into the queue until they're discovered, and numbers act as the king for as long as it doesn't expire or a new king comes in and pops it out.
Yeah.
Okay, that makes sense. Um, well, you really just gave me the high level, but for what it's worth, I'll go ahead and try coding it up.
Okay, okay. Sounds good.
Yeah. Let's see. Okay. Oh, come on. All right, my code share is tweaking madly.
Okay, it's all good, yeah.
Uh, oh, there you go. Okay, okay, cool. Mm. And the reason why this has decent time complexity is because each element can only be added or removed. So at maximum, when each element is added and removed, it would still be O of 2n, which is O of n.
Yeah, yeah.
Um,
Um, yeah. Also, can you like can you reduce it down to like a series of steps before you begin coding it up?
yeah, for sure. So the first thing is I would initialize all the variables that I need. So I would, of course, need the DQ.
Mm-hmm.
Um, and yeah, I would just need the uh yeah, I would just need the DQ,
Mm-hmm.
and then I would have a for loop that acts as the end of the window. So the for loop just goes through the array and acts as the end of the window.
Mm-hmm.
Um, when a new number is discovered, it gets added to the DQ. Sorry, when a new number is discovered, it's compared with the end of the DQ, and all numbers that are less than the new discovered
Mm-hmm.
number gets popped out
Yeah.
before the new number is added.
Yeah.
Um, and on the same iteration, it evaluates whether the front of the queue it has expired or not. And if it has, then it pops it out.
Mm-hmm.
Um, I'm thinking about how the expiration is going to happen. Uh, the expiration happens once there have been k number of evaluations. Like once k candidates have been evaluated to like potentially be added.
Mm-hmm.
So maybe I would also have a counter for how many evaluations have occurred, and every time that or if the index of the current number being discovered is a multiple of k, then I just pop at the front of the DQ. Is that right?
Hmm.
Not no, that's not true. I mean, like I could just like go back to the original idea of using a tuple where each number is stored with its index, and then on each iteration I just evaluate whether the front of the queues, the number at the front of the queue has an index that is
Oh,
less than the window start.
okay, wait. Sorry. Just to clarify for me, um,
Mhm.
so what you're saying is like you create like the queue first, and then you kind of like loop through and have that be like your window, right? And then from there,
Yeah,
you essentially like pop the smaller values from the queue before like like adding like your current one, right?
yeah, that's right.
Okay, so we've established that, and now like um our next kind of problem is to remove like remove like pop like the value from the DQ at like the correct intervals, right? Okay, so
Yeah.
hmm. So okay, so there's like you have like your right pointer, and you have like your left pointer, right? And
Yeah.
like the right pointer like hmm okay mm, okay hmm is there a way you can use your like is there like a okay basically like those two pointers like point to like some sort of value, right? Is there a way you can use those in order to remove it from like from from the DQ?
Oh, I guess. Oh, right. So I see the value of. So I index the array that I'm provided with the index of Windows start, and if the number there is the same as. So if the number in the Windows start position is the same as the number at the front of the DQ, then I pop it. No, I can't do that because I could have multiple values.
Hmm. Okay. Hmm.
I mean, expiring numbers based on the tuple idea is memory safe, like as in like it doesn't use up very much memory, and it also doesn't increase time complexity.
Okay.
So I could go with that.
Let's just code that up. Yeah, that's good. I think it's valid. Yeah.
Okay, okay. Um, so okay, so I want to first have all the libraries that I need, and I say WinMax um, get numbers, and so I'm going to create a queue.
Mhm.
It's a DQ. Uh, and I want to have a window start. No, for window end in range of length of nums. I'm going to go and calculate the window start, which is going to be window end minus k. Of course, the function also needs to get k. So the window start is going to be window end minus k, and the number, so new num, is going to be nums at window end. So first, I want to go ahead and welcome in this new number. The way I welcome in this new number is I potentially add it to the back of the. So I add it to the back of the queue, but not before kind of taking out all the numbers that are smaller.
Mm-hmm.
So while the queue at position length of queue minus 1, so while the last number is less than or equal to the current number or the new number, I want to go ahead and take the value out. So q dot pop, so that pops from the left or the right rather.
Mm-hmm.
So I pop that out, and then afterwards I want to go and q dot append the current value, the new num.
Mm-hmm.
Now, of course, I talked about the index thing, so I don't have to. I can't just add in the number itself. I also need to add in the index of this number.
Mm-hmm.
Um, nope, forgot to make a results array. Um, right, so add that number, and I also want to go ahead and work on the expiry stuff. So if the queue as the beginning, then I want to index for the expiry, which I'm going to put in the first position. So if the first element of the queue and if the expiry of the first element of the queue is less than the window start, then I want to go ahead and take it out of the queue. So queue dot top left.
Mm-hmm.
Let's see. And then, of course, so
Wait, sorry. Wait. So,
uh-huh.
so this is when like you're saying like append like the window. Oh, okay, I see. Yeah. Okay, no, yeah. Keep going. Sorry.
Okay, yeah, no worries. So right now the for loop it works for the general case, but it doesn't work for the beginning of the window when the window is slowly being built up. So what I want to do is I kind of want to just I want to say if if the window hasn't been done built, if it's not done being built yet in the beginning, so if the window end is less than k, what I want to do is I want to just work on building the window. So what does it mean to build the window? It means that I want to go ahead and um, introduce the new number and put it in the queue at the appropriate position.
Mm-hmm.
Um, right.
Mm-hmm.
And then, or rather, maybe I should do this in all cases, and then I'll avoid doing the other stuff with the window start, unless the window end is greater than or equal to k. Whoops, this belongs over here. Okay. And then once I'm done popping out the expired ones, so once I'm done adding this number and also done popping out the expired one, I want to go ahead and evaluate what the current maximum of this window is, which happens to be Q0. So curmax is going to be Q at position 0, and I want to say result dot append curmax. And I'm done. I return result.
Okay. So okay, yeah, yeah, this seems valid. Just to clarify, like walk through like an example from here to here, I guess.
Yeah, for sure. So I'll go in and use the example that you gave me. Let me just quickly paste this down below so that it's easier for me to see. Okay. Okay, cool. So this the win max function is going to start by so it starts with an empty queue and an empty result array. And so the window end is going to start at 0. So the new number is going to be 1. And while the queue at the last position is less than or equal to new number, I want to queue.pop. Maybe I want to add a guard here. So queue
Mm.
and like that
Yeah,
to
good
make
good
sure
catch, good
that,
catch. Yeah.
yeah. So while the queue actually has stuff in it and the last position is less than or equal to new num, I want to queue.pop, but right now there's nothing, so it doesn't happen. And in the queue, I add in the new number 1 alongside of its index 0. So I have 1, 0 inside of the queue as a single tuple. Now, if the window end is greater than or equal to k, it's not that, so you skip. So we set the current maximum to the first element of the queue, and we append the result. Okay, we actually don't do that the unless the first window has been established. So I guess we put that into the if statement.
Mm-hmm.
We have the 3, so new num becomes 3, while q and while q and the last element is smaller, we pop. The last element is smaller. But actually, I think I forgot to read the value here instead of the tuple. Right. So while q and the last element is smaller, we pop it out. So 1 actually gets kicked out. And then I append 3 alongside its index 1. The window is not done building, so we leave it as is. Next one, -1. We see that the number is smaller, so we don't pop. And then we add it in. So the queue now has 3 and 1.
Mm-hmm.
The window is not, oh, it is done building. 0, 1, 2, greater than or equal to, maybe I should do k minus 1 here.
Mm. If okay.
Yeah, so in this case, the window has been built with the -1.
Mm-hmm.
So the window start is now set as the window end minus k minus 1, which is going to be 0. So the window start is 2 and the window start is 0. And if the queue at the first position, so we're doing the expiring, it shouldn't expire yet. So that doesn't happen. The current maximum is the first of the queue, which is 3. That's correct. So it gets appended to the maximum, right? Now we go to -3. New number is -3. Queue exists, and the last element of the queue is not smaller. So we don't pop. We add it in. The queue is now 3, -1, -3. The window is done building, so we check for expiry. There is no expiry. So we read the current max, which is q at 0. That's 3. Maybe I want to do q at 0 at 0 to get the value. And then I append the result to current maximum. So let's skip all the way to the end. So let's say I'm at 7. So at the point of 7, all I would have are 6. Yeah, I would just have 6 in the queue. So new num would be 7. Q, yeah, so we pop 6 and then we append 7 when the window is like done building at this point. So we check for expiry. It isn't expired. So we set the current max to 7 and we append 7, and then we're done. So we return the result.
Mm-hmm. Yeah, I think that's good. Yeah. Yeah,
I see.
that's pretty solid.
What was the thing that you we're gonna suggest as an alternative to my tuple method.
So okay, I can actually just paste the code now. I'll
Mhm.
so you like actually your solution is pretty similar. I think it's just like instead of like using the tuple, it has like a well I guess like instead of the window start and end, it's like the right and the left, but like it's like the same thing pretty much. But
Mhm.
it like it has like this check in order to like just pop it from the left.
If the left is greater than Q at zero, what does Q store?
Well like that's like that's like the DQ. So and
Oh,
Q0 is
does
like
it
the
store
very
the
first element.
indices?
I think
Oh,
so.
I see. It stores the indices and then it does the comparison not by using the number in the queue, but by like indexing for that inside of the array, right?
Mm-hmm.
And that way you can evaluate the queue. Sorry,
Mm-hmm.
that way you can evaluate the uh, you can evaluate for expiry just by reading the number inside of the queue because the queue stores the indices.
Mm-hmm.
Okay, that makes sense.
Yeah. Okay. Let me just rephrase this by saying like maybe I should have chosen like a little bit of an easier question just for myself too.
No, no, bro,
Yeah.
no,
My
bro.
my bad. I kind of fumbled a little bit of it, but
No, 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 no. Like this is actually like this is a perfect question to choose because I've been attempting it before as well.
mhm.
Um, so it was good to walk through this.
Yeah.
But like I did get absolutely pummeled by this question.
Dude, I got fumbled
Like,
by it too, and I'm the interviewer, dude.
bro, I don't know how many I don't know how many Google interviewers are gonna after this interview with me say like I think this is our guy.
No, yeah. Oh. No, no, this is yeah, definitely good practice too. I think like the way you like, I literally can't see anything wrong with the way you approached it. Everything was pretty methodical, like the examples you explained, as well. Yeah, I think but I especially liked how when I was explaining the example, you pointed out like the king issue, like
Right,
having a
right.
successor, because like that's something I didn't like. I like it's because I like understood the problem like that, like the solution the wrong way, but
I
um,
see.
yeah, like I didn't think of that.
Thanks, man.
Yeah, that was good. Um. I'm trying to think of feedback.
I I'm I'm still a little unsure on like is there any value to coding up a brute force? Because I knew the brute force, right?
Yeah,
But
yeah.
I also know that's not what the interviewer wants. Um,
I think in a situation like that, I guess like my feedback would be like to clarify with the interviewer, because like I noticed like you assumed, like you just said like, oh, like the solution's really easy, so like I'm not gonna code it up, right? Maybe like
uh-huh.
during an actual interview, you could be like, oh, so like the brute force solution is this and this and this. Would you like me to code it up, or should I like go ahead and like continue thinking of like the actual solution?
Right, right,
So like that way, like it kind of like gets rid of the ambiguity. But
right. So just ask. Yeah, that's a really good idea. Just to like clarify before
yeah,
making any decision on my own.
yeah, and then also this is I think this is a more like a subjective thing, but in a situation like this, do you think like because I noticed the advice you gave before was to have like multiple examples, right? Running through one example
Mhm.
takes a while. So do you think that would be like okay? Like if you had like if this problem was given like under like let's say like a 40-minute time constraint.
Yeah, so I think like when it comes to running through examples, I think um like when it comes to running through examples, I think generally a just a decently varied test case is like it gives you most of the value in itself.
Yeah.
And the edge case test cases that you might come up with, um, that you do only if you feel like you don't have a grasp of the idea,
Hmm.
uh, by going through the first example. I think ideally you would, but here also the edge case. I think I would go through the just like the moderate example to come with the idea, and then maybe do the edge case
Hmm.
afterwards,
Right. Right.
like after you code up the solution, just to verify that your solution is correct.
Yeah. That
I
makes
mean that
sense. Yeah.
that's what I think.
Hmm.
I not say that's right, but that's my guess.
Mm. Okay. Okay. Yeah. Um. Let me think. Other advice. Yeah. I think. Yeah, everything. Oh yeah. Here's another thing. Um,
Mhm.
I don't know. Like this also might take a little bit of time, but what like when I was saying like like oh I guess like yeah it's like coming up with like pseudocode and like having like a comment, right? Like comment like kind of like going through like at a really high level each step you have to do. I find
Right,
like
right.
that for me personally would be like it's helpful, and maybe
Yeah,
like for
I
like
think
a yeah,
I
hard
think
one,
it
yeah.
definitely would. Yeah, I think it definitely would have helped to add comments there.
Yeah, like even maybe like a really quick like to do or something. So like just like to keep like your head on track. Like
Mhm.
that would help in this like situation. Um, yeah, and then yeah, also good on you for asking the constraints. Yeah,
Oh,
yeah.
thanks, man.
Hmm. Yeah, that's good. It's good. Um, yeah,
Buddy just gave me the solution though. You know what I mean?
yeah. Okay. Sorry, that's also my bad. I should have asked you
No,
like.
no, no, no. That's not your fault. Like you definitely were at a point where it was kind of tough to make it a hint,
Mhm.
to like give out hints. Yeah, because I had absolutely no idea what was going on.
Mhm. Yeah, dude, you know, like, yeah, like this is definitely like a thinker to like, for, like just for me to like understand too. Yeah,
Yeah, so this illegal question, bro.
legal question. Yeah, I think like that's like mostly like the feedback I have though. Like otherwise like the process you have like the process down to like really good. So yeah,
Oh, thanks, man.
yeah.
I think I should have written a search statement though, but
Well,
besides that, thank
it's
you.
kind of hard to do it with I guess you could actually, yeah, but yeah.
Hmm.
Uh, uh yeah. Well, that's the end of this problem. Okay.